Hi students, welcome back. Let's continue with our ad hoc wireless networks. So in the previous video I explained about what is exactly the transport layer protocol for ad hoc wireless networks and the design issues and the goals of uh, transport layer protocol for ad hoc wireless network. Now coming to the next topic, actually the next topic is the classification of transport layer solutions. So this is a classification of transport layer solutions. So transport layer solution for ad hoc wireless network may be TCP over ad hoc wireless network and other transport layer protocols, and these are the different protocols that we use it for transport layer solutions for ad hoc wireless network. So before going to know about all these protocols, so now let's discuss briefly the reason why TCP does not perform well in ad hoc wireless network. So because of not performing well, we are choosing the transport layer solutions for ad hoc wireless network. So now let's see what are the reasons why the TCP does not perform well in ad hoc wireless network. The major reason behind the throughput degradation that TCP faces when used in ad hoc wireless networks. Actually, the main problem here why the ad hoc wireless network is not fully supporting the traditional TCP. Why it is not support? Because the throughput degradation. The throughput degradation that occurs in the TCP, traditional TCP layer. Okay, so the TCP facing the throughput degradation that TCP faces when used in ad hoc wireless networks. So in the ad hoc wireless networks, the throughput degradation is faced by the TCP. So further reasons, some of the reasons the TP does not perform well in ad hoc wireless network. Now let's see what are the reasons. The first is misinterpretation of packet loss. The TCP does not perform well in ad hoc wireless network because of misinterpretation of packet loss. That means, suppose if you take the traditional design of TCP. In traditional TCP design, the packet loss is mainly attributed to network congestions. Only because of network congestions, the packet is losing in traditional TCP. But whereas in ad hoc wireless network, it experiences a much higher packet. In wireless conditions, we already know that in the wireless network, there is a more packet loss when compared to the traditional TCP design. So, the ad hoc wireless network experience a much higher packet loss due to high bitrate, increased collections, etc. So, because of all these reasons, the ad hoc wireless networks experience a much higher packet loss. And the next reason, frequent path breaks. Because of the frequent path breaks, the TCP does not perform well in ad hoc wireless network because of the frequent path breaks. How it is possible? Let's see. If the route re-establishment time is greater than the RTO period of the TCP sender, then the TCP sender assumes congestion in the network retransmission, loads packets and initiate congestion control algorithm. This leads to wastage of bandwidth and the battery power. Because of the frequent path breaks, there is a lot of congestion control is established at the sender side. Okay, so which leads to the wastage of the bandwidth and battery power. So because of this reason the TCP will not allow it's not perform well in the ad hoc wireless networks. And another reason, effects of path length. So here the effects of path length means as a path length is increasing, the throughput will be decreased. How it is? Let's see here. So this is the path length here and the TCP throughput here. The variation of TCP throughput with path length. So here whenever the path length is increasing, okay, the throughput is decreasing. Whenever the path length is increasing, the throughput is decreasing. In the same way, the probability of the path break is also here. It's the path length, that is nothing but the number of hops, and here the probability of the path breaks. So there is a path breaks chance will be there. When it is length is increasing, the path breaks is also increasing. The variation of the probability of the path breaks with the path length. Okay, so this is another reason. The effects of the path lengths is also one of the reason that the TCP does not perform well in ad hoc wireless network. And coming to the next reason, misinterpretation of congestion window. So we already discussed that the misinterpretation of packet loss is one of the reason, and the congestion window is also one of the reason for the TCP does not performing well in ad hoc. So what does this see? When there are frequent path breaks, the congestion window may not reflect the maximum transmission rate acceptable to the network and the receiver. So obviously, so whenever the path breaks are more, number of path breaks are increasing, the congestion window may not reflect the maximum transmission. It may not transmit the maximum amount of packets, which is the rate acceptable to the network. Now coming to another reason that the TCP does not perform well in ad hoc wireless network because of asymmetric link behavior. So what is this asymmetric link behavior? Here the radio channels used in ad hoc wireless networks has a different properties such as location dependent contention, directional properties. So which leading to the asymmetric links. And this can lead to TCP invoking the congestion control algorithm and several retransmissions. And another reason why the TCP does not perform well in ad hoc wireless network is because of the unidirectional path. So here the TCP always follows the unidirectional path. The TCP relies on end-to-end acknowledgement for ensuring reliability. Path breaks on an entirely different reverse path can affect the performance of the network as much as the path breaks in the forward paths. So because of the unidirectional path, the TCP does not perform well in ad hoc wireless network. And the last reason is a multipath routing. For TCP, multipath routing leads to the significant amount of out of order packets. Multipath routing. So here the TCP, the multipath routing leads to the significant amount of out of order packets when intergenerates a set of duplicates, that is a duplicate acknowledgements, which causes additional power consumption and invocation of the congestion control. So because of the multipath routing, there is a chance for additional power consumption because of the duplicate acknowledgements received by the receiver and the invocation of congestion control. Okay, so these are all the different reasons why the TCP does not performing well in the ad hoc wireless network. So let me tell you again, the misinterpretation of the packet loss and the frequent path breaks, effect of path lengths, misinterpretation of congestion window, asymmetric link behavior, and because of the unidirectional paths and a multipath routing. So because of all these reasons, the TCP does not performing well in ad hoc wireless networks. Thank you.